Thanks for watching this screencast on solving systems by graphing. Our goal for the screencast is learners will be able to solve a system of equations by graphing. So here's the definition of a system of equations. A system of equations is a set of two or more equations that collectively, together, contain two or more variables. I'll give you a couple of examples here. Once I turn on the pen, that is. So here's a system of equations. X plus 5 equals 12, and 3x minus 2y equals negative 6. That's a system of equations. There's two of them. Collectively, they contain two or more variables. The solution to a system of equations is any set of values for each variable that makes every equation in the system true. So any ordered pair, in this case, x comma y, that makes both equations true is called the solution to this system. And our goal when we ask you to solve a system of equations is for you to try to find the ordered pair that would solve each equation in the system. So there are three pretty short screencasts coming up in your feed that are all going to be focused on solving systems of equations. This is a skill that you probably got pretty good at in Algebra 1, but maybe you haven't used it a lot since. So we're going to look back at it here. The one we're going to focus on in this screencast is graphing to solve. It says solve this system by graphing. So I've got a system of equations here, two equations that both have x and y, and I'm going to try to solve that system by graphing the two equations. I'm going to do some color coding here. I'll do this one in blue, and I'll do this one in red, okay? So the graph of y equals x minus 4, we know how to graph things that are in slope-intercept form. I can graph y equals x minus 4 by giving you the y-intercept of negative 4 and the slope of 1. 1x means I'll go up 1 and right 1 and plot other points. And I like to try to fill that whole pattern as much space as fits on the graph. Let's connect that line here. There's a good graph of y equals x minus 4. Let's do the same thing for y equals negative 2x plus 5. That line is going to have a y-intercept at 5. And the slope here is negative 2, which means to find other points on the line, I need to go down 2 and right 1. Down 2 and right 1. Hey, that point looks important. Down 2 and right 1. Down 2 and right 1. And that line looks something like... Well, I missed a couple points there, but you get the idea. So if the solution to the system of equations is any ordered pair that solves both of them, and if a line graph shows you every ordered pair that solves each individual equation, what's the ordered pair that solves them both? Yeah, it's this one right here, right? What is that ordered pair? That's the ordered pair x is 3 and y is negative 1. 3, negative 1 should solve this system. And a good way to check this is to just confirm that that ordered pair works in both equations. If I let x be 3, 3 minus 4 is negative 1, that one works. Here if I let x be 3, negative 2 times 3 is negative 6, negative 6 plus 5 is negative 1. That is the solution, isn't it? Okay, here's another one. We're going to try to solve this system, y equals 3 halves x minus 1, and y equals 3 halves x plus 4. So for the one I'm going to do in red here, y equals 3 halves x minus 1, the y-intercept is negative 1. The slope is 3 halves, up 3, right 2. Up 3, right 2. I could even go down 3 and left 2 to fit that pattern. Looks to me... There's a pretty good sketch of the graph of the red line equation. Let's do this one in blue. Y equals, 3 halves x plus 4. That line's going to have a y-intercept of 4. It's also going to have a slope of 3 halves, up 3 and right 2, or down 3 and left 2. Down 3 and left 2, etc., etc. So the graph of this line Looks something like that. Ooh. These lines are parallel, aren't they? In fact, I know they're parallel because a couple of weeks ago we decided that parallel lines are the lines that have the same slope. These lines are parallel. So where will these cross? They don't. They don't cross. This system has no solution. There's no ordered pair that solves both of these. And that will be the case if you're ever asked to solve a system where both line graphs are parallel to one another. So kind of an odd second example. And here's a different example altogether. Solve the system y equals 3x plus 2 and 2x plus 2y equals negative 12. So I will designate some colors here. I'll do this one in red, and I'll do this one in green. The red line, we're ready to graph. Y equals 3x plus 2 has a y-intercept of 2 and a slope of 3. Like roughly so. Yeah, let's try that again. Better? Unfortunately, though, this green equation is not the easiest to graph. One way to solve that problem would be to solve it for y. So let's do that. Let's solve this thing for y. Let's take the 2x here, make it a negative 2x on this side of the equation. So we have 2y equals negative 2x minus 12. And if I want to divide both sides of this equation by 2, I think we can get it in slope-intercept form now. So y equals, that would be negative x minus 6. So that equation will have a y-intercept of negative 6. It has a slope of negative 1, which I think of as down 1, right 1. But in this situation, it's probably better to go up 1 and left 1. Okay, that point looks important. Even if you identify what the solution is going to be, go ahead and make that second line. So there's our second line. What's the solution of this system? Looks to me like negative 2, negative 4. And I'll let you confirm that that is indeed the solution. Okay, this one's yours to try. See if you can sketch the graph of this system of equations and then use your graph to find a solution. Hit pause. Alright, let's check it out. This one that I'm going to do in blue is ready to graph. It's in slope-intercept form. I'll make the y-intercept negative 2. I need a slope of negative 1/4. I need to go down 1 and right 4. Or up 1 and left 4. Something like that. Now, the one that I'm going to do in black is not ready to graph yet. I want to solve it for y most likely. So I'll make this a negative 3x on the right side of the equation. Don't lose this negative sign here. It's negative 2y equals negative 3x plus 4. And now to get y by itself, I need to divide every term by negative 2. So what I have is y equals positive 3/2 x, and 4 divided by negative 2 is a negative 2. And that one's ready to graph now. It's got a y-intercept of negative 2. Oh, that's nice. It's got a slope of 3/2, up 3 and right 2. And the line, I believe, would look something like this. So what's the solution of this system? It's right there. They have the same y-intercept. It's right there. It's 0, negative 2. How'd you do? Thanks for watching.